Hey everybody, in this video we're going to continue talking about systems of equations, but this time we're going to use a new way of solving them called substitution. So just like in graphing, we have three steps that we're going to use to solve with substitution every time we have a system of equations. So step one is going to be to solve one equation for either x or y. It doesn't matter which one. What I'm going to suggest is that you try to look for the one that's easiest to isolate. And the more we practice it, the more you're going to see what that means. But just always know you can solve for either one. Step two is to substitute this expression into the other equation and solve for the variable. So whether you've solved for x and y, x or y, you're going to take that equation and put it into the other one, wherever that x or y is. Once you do that, and once we do a couple examples, you'll see it, but there's only going to be one variable in that whole equation then. We're going to isolate that variable and solve for it. So that's another way to think about it, is we're going to isolate that variable, but we'll have it equal to a number. We're not going to know what that number is. Then we're going to take that answer, we're going to substitute that answer back into the other equation from step one, and then we're going to solve for the other variable. Now remember, the one thing that hasn't changed, our method is changing in how we're solving the system of equations, but our answer remains the same. We are still looking for a point xy. When we were looking at the graphs, we knew that that point of intersection was our answer, our xy. In substitution, we're doing more of that algebra approach where we're going to find the x and the y values that if we put them into either equation or both equations, it's going to make the equation true. So we're dealing more with the equations in this method, and we're dealing more with numbers and using our rules of algebra to solve for these x and y points. But our answer is still the same. It's still going to be an x and a y coordinate. Okay, so here's our first example. We have our two equations and we have two variables, our x and y. So step one in substitution is to solve for one of the variables, either x or y. What's nice here is in both equations, we've already solved for y. We only need to do it in one equation. In this case, that's been done for us in both. So what we're doing in substitution is we're saying, okay, we know that in the first equation, y is equal to 4x minus 1. That is what y is. So since this is y, I can take that whole expression and put it in for the y in the other equation. Y is equal to 4x minus 1. So whatever y is, I can substitute it into that other equation. Okay, so if I take this 4x minus 1 and I put it in here, what I'm now going to have is 4x minus 1, that's what y was, equals 2x minus 5. I'm just going to finish that equation. So I took 2x minus 1 and I put it in for y because I knew that's what y was equal to. Okay, so now after I substitute in either x or y, in this case I substituted in y, into the other equation, I'm going to solve for the variable. Now let's look. The only variable in this equation now is x. It's in two places, but I only have one variable in the entire equation. So my job now is to solve for that x. I want to get x by itself. So what I'm going to do first is I'm going to subtract 2x from both sides. My goal is to have the x's on one side and the constants on the other. So when I subtract 2x from 4x, that gives me 2x. I still have the minus 1 on the left, and now the two x's on the right cancel out, and I have minus 5 on the right. So now all of my x's are on the left, and my job now is to move all the coefficients to the right because I want x by itself. So to do that, I'm going to add 1 to both sides because I have to do the addition and subtraction first rather than the division. So I'm going to add 1 to both sides. On the left, that cancels. So I'm left with 2x on the left equals -5 plus 1. I make that less negative, so I'm going to have that be -4. We're almost there. X is almost by itself. Now we have to say to ourselves, what is bothering x? And that's the 2. The operation going on between the 2 and the x is multiplication. So to undo that, I'll do division. So I'm going to divide 2 on both sides. Those cancel. So on the left, I'm left with x equals -4 divided by 2. Negative divided by a positive, we'll leave it as a negative. 4 divided by 2 is 2. So x is equal to -2. Remember, we're looking for our solution to the problem. So here's where I'm going to put my final answer. We know that the x value, the x part of the coordinate, is -2. That's what we just solved for. X is -2. But now we need to solve for y. So what we're going to do is we're going to take this x value of -2 and we're going to put it in that first equation where there is an x. That's going to let me solve for y. So I'm going to rewrite that whole equation. So I've got y equals 4x minus 1. That's that equation up here that I just highlighted. I'm going to take this x value, I'm going to take this -2, and I'm going to substitute it in for x, because that's what x is. So what that's going to give me now is that y equals, I'm going to use a different color here, y equals 4 times -2 minus 1. Now I'm going to solve. Y equals 4 times -2 is -8 minus 1. Y equals -8 plus -1 is -9. This is my y value for my final answer. Remember up here I've got x comma y. We solved for x before, and now we know that the y value is actually equal to -9. A nice part about systems of equations is you can check your work at the end of this to make sure you're right. So the way we would do that is to take one of the equations. I'm going to take that second one, y equals 2x minus 5, and see if my point -2, -9 works. So what that means is I'm going to substitute -9 in for y, and I'm going to put in -2 for x. So we've got -9 equals 2 times -2 minus 5. So I took my x and my y and I plugged them in. So now that says that -9 equals -4 minus 5, or this is plus a -5. -9 equals -9, which is true. Ideally, you're going to do that into both equations to make sure that you're right. But that's a nice thing about these is you can always take the numbers that you find, take that coordinate that you find as your final answer, and put them back into the equations and see if they work. The true solution to one of these videos, or sorry, the true solution to any of these problems is the one coordinate, x comma y, that makes both of the equations true. So if you take the time to check your work and plug these numbers in, you're going to know if your answer is right or not. Here's example number 2. So in example number 2, we have our two equations again, and we have two variables. Step 1 says that we need to isolate either x or y in one of the equations. Well, what's nice is in this first equation here, y equals 6x, the y is isolated. So we know that y is equal to or is 6x. Step 2 says that we're going to substitute the expression into the other equation and then solve. So if y is equal to 6x, then I can take this 6x and plug it into the other equation where there is a y. So we're going to write that out. I'm going to rewrite the second equation, 2x plus 3. Now here's that y value. So I need to take what y is equal to from the other equation and plug it in. So we've got 3 times y is 6x. Keep writing the equation, equals -20. So by substituting in 6x, which is equal to y, I have 2x plus 3 times 6x equals -20. From here, we're just using our order of operations to try to solve for x, so we can then, solve for y. So order of operations, I have to multiply first. So I have 2x plus 3 times 6x gives me 18x equals negative 20. Now I can add these together because these are like terms. Since they both have an x, then I can add them together. So 2x plus 18x, I can add them, so I just add their coefficients. 2 plus 18 is 20x equals negative 20. Now I'm going to divide both sides. I want x by itself, so the thing bothering x is 20, and that's multiplication going on between. So I'm going to divide both sides by 20. On the left, those will cancel out. Negative 20 divided by 20 is just equal to negative 1. So again, we're going to be writing our answer. Here's our answer box. We're going to be writing it in the form of a point. That point has an x-coordinate of negative 1. We've solved half the problem already. So now what we need to do is solve for the y value. That's the piece that we're missing in that ordered pair. So we're going to take our x value and we're going to plug it in and we're going to solve for y. So I'm going to take that first equation that we used to plug into the second one. We're going to use that one now. We already used the second equation in step 1. Now we're going to use the second one. So we have y equals 6x. That's the equation we're working with. I know that x is equal to negative 1, so I'm going to take that and I'm going to plug it in where there's an x. So y equals 6 times negative 1. Where there was an x, now I have a negative 1. 6 times negative 1 is negative 6. So my y coordinate is negative 6. The answer to the system of equations, the one point, x comma y, that makes the equations true is negative 1 comma 6. Let's plug it in just to see if we're right, just to double check. So let's take that equation, 2x plus 3y equals negative 20. So I've said that my x, I'm going to substitute in, we said that x is negative 1, plus 3, we said y was equal to negative 6, equals negative 20. We'll squeeze it in there. So 2 times negative 1 gives me negative 2, plus 3 times negative 6 gives me a negative 18, equals negative 20. We're going to add those two together. Negative 2 and negative 18, the signs are the same, so I'm going to add them together. Negative 20 equals negative 20. And that is true. So I know that my point is right. Again, I should do it in the other one as well, so let's just do that. Y equals 6x. We said that y was equal to negative 6, which equals 6 times negative 1, because negative 1 is our x value, so I've just substituted these in. So negative 6 equals 6 times negative 1 is negative 6. That is also true, so I know that this answer of negative 1, negative 6 is correct and is my final answer. All right, example number 3. We're going to do exactly the same thing. Step 1 is to isolate one of the variables in one of the equations. Again, we're super lucky that in this one, this second equation here, the y is already isolated. So that makes our life a whole lot easier. One less step to do. So we know that y is equal to x plus 9, which means we can take this x plus 9 and plug it in the other equation wherever there is a y. So that's what we're going to do. So we're going to start by writing the second equation. We're going to say 3x plus 8. Okay, well now there's our y. So we're going to substitute in what y is equal to, x plus 9, which equals negative 5. So where there was a y in this equation, I substituted in what y is equal to, and that is x plus 9. Now, something to be super duper careful about. When you're using these, when you're doing these problems, you want to make sure that when you're substituting in an expression, that you're using parentheses. So if you look in this equation right here, I'll highlight it a little bit in yellow. When I substituted in x plus 9, I did so in parentheses. Yes, it does make a difference because I need to distribute that 8, and I wouldn't be multiplying the 8 by the x and the 9 unless those parentheses were there. So what I'd like you guys to get in the habit of doing is when we have an expression once we isolate a variable, so we have this x plus 9, it's not just x, it's not 2x, we've got an expression there. What I want you to do is get in the habit of actually putting those in parentheses in the problem, and you'll see me doing that as well, so that when you substitute it in the second equation, you remember to use those parentheses as well. It is super important. If you don't do that, you will end up getting the wrong answer. So pay super close attention to that. So now our job in this new equation that we've created is to solve for x. So order of operations, I've got to get rid of multiplication first, or I have to do that multiplication first. So I'm going to distribute the 8 to the x and the 9. So I've got 3x plus 8 times x is 8x, plus 8 times 9 is 72, which equals negative 5. Okay, now I'm going to combine like terms. So the like terms on the left are the 3x and the 8x. So I have 11x plus 72 equals negative 5. Now I'm going to subtract 72 from both sides. I want to get this 11x by itself, so I'm going to subtract 72, and then I'm going to have 11x equals, because these cancel on the left, equal negative 77. The signs are the same, so I add them together, but it stays negative. Now I want that x by itself, so I'm going to divide both sides by 11. The 11 and the x are being multiplied, so to undo it, I'm going to divide. The 11's on the left cancel out. So I have x equals negative 77 divided by 11 is going to give me negative 7. So again, here's my answer box. I know I'm going to have a point that's x comma y, and I know my x is equal to negative 7. Halfway there. Now we're going to take that negative 7 and we're going to plug it into that first equation. So I'm going to rewrite it, y equals x plus 9. But I know that x is equal to negative 7. So I'm going to say y equals negative 7 plus 9. I took my x value and I substituted it in for the variable. Now I can solve for y. Y is going to be equal to negative 7 plus 9. They are different signs, so I'll subtract them and take the sign of the bigger one. So 9 minus 7 is 2, and the 9 is bigger, which is positive, so my answer is positive 2. Y equals 2. There's my final answer. What you can do is pause the video, plug those in to the two equations that we started with, and see if it worked. All right, this is example 4. So number 4 is a little bit different because even though this first equation has a variable isolated, it's not y, which is the one we've been dealing with. Up to this point, every problem has had y isolated. In this case, x is the one that's by itself. The nice thing is, in substitution, it doesn't matter which one you solve for, so we can actually use this equation as it's been given. So what we're going to do, what this is saying is that x is equal to 4y plus 7. So I'm going to take that 4y plus 7 and I'm going to substitute it in for the x, because it's x that's equal to it, in the other equation. So whichever variable you isolate is the one that you're going to replace in the other equation. Okay, so what this is going to look like, don't forget, we're going to put this in parentheses so that we remember to do it in our newly written equation. We're going to start by writing that second equation, 2, but there's the x. This is what I want to replace, so I'm going to replace it with the parentheses from the first equation, 4y plus 7. Now we're going to keep going with the rest of that second equation, minus 6y equals 12. Okay, so from here, now if you notice the variables in this equation, here's a y and here's a y. By doing that substitution, we don't have an x in this equation anymore, so we can actually find the number that is equal to y. So let's do that. We're going to start by distributing the 2, multiplying it through that set of parentheses. So 2 times 4y gives us 8y, plus 2 times 7 is 14, minus 6y, nothing we can do with that yet, equals 12. Now we're going to combine like terms. So the like terms on the left are the 8y and the minus 6y. We're going to subtract those because this is plus a negative 6y. So 8 minus 6 gives me 2. 2y plus 14 equals 12. Okay, now I'm still trying to get y by itself. So this time I'm going to subtract 14 from both sides. When I do that, that cancels with this on the left. So I have 2y equals negative 2. Y is almost by itself. We're almost there. We just have to divide by 2 to undo that multiplication. If we do it to one side, we have to do it to both. So on the left, the 2's cancel. 2 divided by 2 is 1. So we have y equals negative 2 divided by 2 is negative 1. So now here's my answer box. Again, I'm still answering with a point, with an xy coordinate. But now I'm going to fill in the y first. Y is equal to negative 1. So again, it doesn't matter which one you solve for first, you just solve for one and then use that to solve for the other. So now we need to know what x is. Well, we know from that first equation that x is equal to 4y plus 7. So now I can take this negative 1 value for y and plug it in for y in that equation. So x is going to be equal to 4 times negative 1 plus 7. X is 4 times negative 1, negative 4, plus 7. And then we'll actually do that addition out. So negative 4 plus 7, or 7 minus 4, x is equal to 3. And there's our point. Again, you want to make sure that your answer is right. So you would take these x and y values and plug them into both equations to check your work and make sure you're good to go. All right, here's example 5. Example 5 is a little different because neither equation has a variable that's by itself. In the first equation, we have 2x plus y equals negative 2. So in this case, neither the x nor the y are on a side of the equal sign by itself. And in the second equation, 5x plus 3y equals negative 8, those variables are on the same side as well. So our first step is going to be to take one of those equations and get a variable by itself. Now, you could honestly pick this x or this y or this x or this y. You can pick any variable you want to solve for. It's totally up to you. But there are going to be times where certain variables are easier to solve for than others. And what you should look for is a variable that does not have a coefficient. So remember, let's think back. What is a coefficient? A coefficient is a number directly in front of a variable where they're being multiplied. So in this case, this 2 is a coefficient. This 5 is a coefficient. This 3 is a coefficient. So the first x, the second x, and the second y all have coefficients. Well, technically, this y also has a coefficient, but it's a coefficient of 1. A coefficient of 1 means that that is going to be a really easy variable to solve for because we're not going to have to divide in the end. So anytime you see a coefficient of 1 or a variable by itself, that's the variable you should solve for. If you have more than one option, awesome. That means you have even more choice in what you'd like to solve for. In this case, we only have one variable that doesn't, or that has a coefficient of 1. So we are going to start by isolating or solving for that y. So let's do that first. We have 2x plus y equals negative 2. So I just rewrote that first equation down here. We want to get y by itself. So to do that, we have to say to ourselves, what's bothering y? And in this case, that's the 2x. 2x and y are being added, so I'm going to subtract 2x from both sides of the equation. So now I have y equals negative 2x minus 2. Those are both negatives. Be super careful about that. But now y is isolated. I have y equal to the rest of the expression. Y is by itself, nothing being added, nothing being multiplied. So I can take whatever y is equal to, and I'm going to substitute it in for this y in that other equation. So that's why I did that, so that I could find a variable that I can take the whole expression and substitute it in. So I'm going to start by writing that second equation, 5x plus 3, there's my y. So instead of y, I'm going to write that expression that I just solved for. Y is the same as, or y is equal to, negative 2x minus 2. And then I finish that second equation. 5x minus 3y, technically that red writing is y, equals negative 8. Okay, so now I only have x in this expression, in this equation. So I have to solve for x. I start by distributing. I'm going to multiply through. So I have 5x minus 6x. 3 times negative 2 is negative 6 equals negative 8. I'm going to combine my like terms. 5x minus 6x, so they are like terms, they both have an x, so I'm going to subtract the coefficients. 5 minus 6 is equal to negative 1x, or just negative x, either way. Minus 6 equals negative 8. Okay, still need to get x by itself, so I'm going to add 6 to both sides. When I do that, I have negative 1x on the left. The 6's cancel because they undo each other. Equals negative 8 plus 6. If you owe me $6, but then you pay me 6, now you only owe me $2, but it's negative 2. Divide both sides by negative 1. Then we have x is equal to negative 2 divided by negative 1 is a positive 2. So there's my x value. Now, I'm not quite done though, because I only have, if I'm trying to solve, fill in my my ordered pair in my solution box, now I only have the x value. I still need to solve for y. So I'm going to do that by taking this x and I'm going to plug it into that equation where it's solved for y already. So I have y equals negative 2, but instead of x, I'm going to write in what we found for x, which is 2 minus 2. So that gives me y equals negative 2 times 2 is negative 4 minus 2. I'm going to come over to the right here. Y is equal to negative 4 plus a negative 2 is negative 6. There's my y value. So my final answer, I've got to take that y coordinate and plug it in my point. My final answer is 2 comma negative 6. Again, number 6 is similar to number 5, that we have to isolate one of the variables in one of the equations to get started. So the way we're going to determine which one is the easiest to work with is we're going to look and see which variables have coefficients. So if we look at the first equation, this x has a 2 in front of it. This y has a negative 3 in front of it. In the second equation, the first x has a 2 in front of it. But in the second equation, y is already by itself in terms of a number being multiplied in front. So it's that y that we're going to try to solve for to isolate first to start our substitution. So I'm going to take this second equation and I'm going to rewrite it. 2x plus y equals 9. Now remember, you really can choose any of those 4 variables you want. You could have picked the 2 from the first equation. You could have picked the x in the first equation. You could have picked the y in the first equation. I'm just telling you that we want to look for the ones that are easiest. And the ones that are easiest are going to be the ones that have a coefficient of 1 out in front. Okay, so we decided in this equation that we really want to isolate this y. So to do that, we have to get rid of the 2x on the left. Those are being added, so we're going to subtract 2x from both sides. So y is equal to negative 2x plus 9. Now I have what y is equal to. Y is equal to negative 2x plus 9. So I'm going to take that and I'm going to replace the y in the first equation that we haven't used yet. I'm going to take this y value, and instead of writing y in that first equation, I'm going to put in negative 2x plus 9. So I'm going to start by rewriting that whole equation until I get to y. So I've got 2x minus 3. Oh, there's my y. So now I'm going to put in that set of parentheses. Negative 2x plus 9 equals negative 11. Okay, now I need to solve for x. So I'm going to distribute the negative 3. Don't forget that that negative goes with the 3. So I have 2x plus negative 3 times negative 2x. Negative times a negative is a positive. 3 times 2 is 6, so we have 6x. Negative 3 times positive 9 is minus 27, or negative 27, not 29, 27, which equals negative 11. Now my job is to combine the like terms. So those are the ones with the x's. 2x plus 6x gives me 8x minus 27 equals negative 11. Now I'm going to add 27 to both sides. I'm trying to get that x by itself. When I add those together, they cancel on the left. So I have 8x equals negative 11 plus 27. Okay, so we've got 27, a positive 27 minus 11. If you have to do that out, no problem. That's going to give us 16. 7 minus 1 is 6. 2 minus 1 is 1. So 8x equals 16. The 27 was bigger, and that's positive, so that 16 should stay positive. Now I still need to get x by itself. The 8 is bothering it, so I'm going to undo the operation between them. The 8's now cancel. So x is equal to 16 divided by 8 is 2. When I'm writing my answer, I'm going to have that ordered pair, and I know that the x value, the first one, is 2. Now I'm going to take that 2 and I'm going to plug it in for x in the equation where we've already solved for y. We're trying to find what y is so we can plug that in our coordinate over here. So we're going to do that by substituting in that value of x. So we know that y is equal to negative 2. There's my x. Instead of writing x, I'm going to write the 2 that we know is what x is equal to, plus 9. So y is equal to negative 2 times 2 is negative 4 plus 9. Y equals negative 4 plus is 5. So we're going to take that y value of 5, put it right in our ordered pair, and our final answer is 2, 5 as a point, as an xy coordinate. Again, you want to take these answers, the x and the y values, and plug them into the original equations, and just make sure that everything works out. Make sure you have true statements at the end of them, and then once you know you've confirmed it in both, you know you have the right answer. Number 7, again, we want to find the variable that's the easiest to solve for. The only variable in both of these equations that does not have a coefficient, or that has a coefficient of 1 without another coefficient, is that first x. So that's going to be the variable that we're going to solve for to start our substitution. So we can rewrite that equation, x plus 5y equals 4. Again, we're solving for this x, so we want to get rid of anything that's bothering it. To do that, we're going to subtract 5y from both sides. X is then, these cancel out, equal to negative 5y plus 4. This is what my x is equal to. So this is what I'm going to take and substitute in for x in that second equation. That's what I'm going to substitute in right there. So I'm going to start writing the second equation, but instead of writing x, so here's 3 times x, instead of writing x, I'm going to put in negative 5y plus 4, that is x, plus 15y equals negative 1. Now I'm going to distribute. So I have 3 times negative 5y gives me negative 15y. 3 times 4 is 12, so negative 15y plus 12 plus 15y equals negative 1. Now I'm going to combine the like terms. So on the left, my like terms are the ones that have a variable of y. So negative 15y plus 15y, those actually undo each other. If we had negative 15 plus 15, you owe me $15, but you pay me $15, you don't owe me anything anymore. So when we add those two numbers together, they go away. That becomes 0. What I'm left with is that 12 equals negative 1. Now, there are no more variables. So my question to you is, does 12 equal negative 1? Are those the same? And the answer is no. So here's the situation. Go back, check your math. This is so weird. Why do I have something that isn't equal to something that's true? Why do I have an equation that's not right? Well, what this means is if I were to put these two lines, our two original equations, if I were to put these on a graph, since what we're getting is a false statement, that means that those lines are parallel. There is no intersection point of these two lines. There is no x or y value that is going to be the same for both and make both statements true. We have parallel lines. There is no solution to this set of, to this system of equations. So what you might want to do, go on Desmos or even try to graph these on your own. If you were to plug these equations in, you're going to see that those two lines that are created are in fact parallel, that they do not intersect anywhere. Now, if this happens in the course of you doing a problem, if you find that you get some weird answer where something is supposed to be equal to something else, but you know they're not right, don't be super quick to just say, oh, wrong, no solution. Make sure you go back and check every step along the way to make sure that the work you've done is right before you just assume no solution. It's a really convenient thing to be able to say, oh, I can stop my problem early, it's no answer. But make sure you're really going through and double checking your work. But know that there are going to be certain situations, just like this number 7, where you might have two lines that are parallel. Therefore, there is no solution to this system of equations. Here's number 8, where we're going to do the same thing. We need to get one of the variables by themselves. Just with a quick glance at the two equations here, you can see that the x in the first equation is the only one that has a coefficient of 1. So that's going to be the equation that we're going to work with first to find our substitution. So I'm going to rewrite x plus 4y equals 0. We want to get this x by itself. So to undo what's bothering it, we have to subtract 4y from both sides. When we do that, we end up with x equals, these two cancel. 0 minus 4y, I've got minus 4y. So x is equal to negative 4y. That's what I'm going to substitute in for x in that second equation. It's what x is equal to. So I'm going to start by writing that equation 3 times x is negative 4y, substituted that in for x, plus 2y equals 20. So now I'm going to multiply 3 times negative 4y, which gives me negative 12y, plus 2y equals 20. I'm going to combine my like terms, negative 12 plus 2. So we can add those together because they both have y's. Negative 12 plus 2 gives me negative 10y equals 20. I need to get rid of the negative 10. That's what's bothering y. So to do that, I'm going to divide both sides. That will cancel on the left. Y is equal to 20 divided by negative 10. Positive divided by a negative gives me a negative. 20 divided by 10 is 2. So my y value is equal to 2. Here's my answer box. I'm going to write it as an ordered pair. The y value, that second coordinate, is the negative 2. But I have to find what y is. So I'm going to use this equation where I've technically already solved for y, and I'm going to substitute what we found for y in it. Sorry, we solved for x. So x is equal to negative 4, but instead of y, I'm going to write in negative 2. So x is equal to negative 4 times negative 2 is a positive 8. My answer is 8 comma negative 2. But again, don't forget to check your work. All right, this is the last example for this video. So again, we want to look at these two equations, find the variable that's going to be the easiest to isolate first, and that is going to be this y that has the coefficient of 1. It's the only variable with a coefficient of 1. So I'm going to rewrite 2x plus y equals 18. I want to get y by itself, so to do that, I'm going to subtract 2x from both sides. So I have y equals negative 2x plus 18. Now I know what my y is equal to. Don't forget those parentheses. And I'm going to take that y. Now here's a little different. We use the second equation to find our y value. So we need to take this y and put it into the first equation. We want to make sure we're always substituting into the equation that we didn't use first. So I'm going to substitute this y into the first equation. So I have 6x plus 3. There's my y that I'm going to substitute in, negative 2x plus 18 equals 54. I'm going to have to distribute first. So I'm going to start by rewriting. So I've got 6x plus, 3 times negative 2x gives me a negative 6x. 3 times 18 gives me 54 equals 54. Now I'm going to combine like terms. So 6x plus a negative 6x, well, those cancel each other out because they're the same number, opposite signs. So that actually becomes 0. What I'm left with is that 54 is equal to 54. Again, just like number 7, this is one of those weird answers. Well, my question to you is, when is 54 equal to 54? And the answer is all the time. So this statement, 54 equals 54, is always true. It doesn't matter what x value I put in for one equation or what x and y I put in for one, it's also going to work for the other. If we have a statement that is always true, what that means is that we've actually found two equations that are going to create the same line. And you can even go ahead and try to solve for y equals in both of these, isolate y, and you're going to see that the slope and the y-intercept are the same for both. We have the same line. So we don't just have one point that is going to work for both. We have an infinite number of points. Our answer for this is infinite because they are the same line. Okay, so anytime you have a statement that is true, 54 is equal to 54, that means we have the same line and our answer is going to be infinite number of solutions, or we can even just write the infinity sign. So those are a bunch of examples on how to use substitution to solve a system of equations. Hopefully you guys are getting a little more familiar with what we're trying to do and how we're doing the algebra to find our final answer and the form that our final answer is going to be written in, an XY point, don't forget. So play with those a little bit. Your homework is going to be a couple more problems on this, but hopefully you're getting more comfortable. If you have questions, if you don't understand anything from the video, please reach out as soon as possible. More than happy to go through either these problems with you or even some new ones. So I hope you guys are all doing well. Hope the math is going well, and I can't wait to talk to you guys soon. Have a good one.